This is the Tesoro AI podcast with Darius Gant. AI is changing the world and fast. This episode is coming to you courtesy of Tesoro AI, the #1 recruiting service for software development and AI talent.
All right, Yi, welcome to the show. I appreciate you taking some time out to join us.
Happy to be here.
Absolutely, absolutely. So excited to get into the topic around Relari, but before we go there, I want to talk a little bit more about your background. You kind of have this interesting mix of finance and technology. So would love to hear more about your kind of early career and your backstory, and then why AI? How'd you get into this world of AI?
Yeah, sure. Happy to walk through that. So I was a computer science major in college. I went to Northwestern, and it was interesting that when I was in freshman, the computer science class was, I think it was 20 person per year, but by the time I was graduating, there were like over 200 people majoring in computer science. So it's definitely becoming big at that time. But I think the job market was still picking up. Back then, the most popular jobs were still investment banking, consulting, versus going to the big tech was not that really big of a thing. So I sort of followed the most popular route and going to investment banking, even though I studied computer science. But I still wanted to do tech. So I ended up in the Palo Alto group of Bank of America's investment banking practice. And over there, I worked on some very exciting things. For example, like the IPO of Uber and some of the other iconic companies at the time, internet companies and software companies. And really, when I got into AI, obviously I took AI classes in college, but when I got to see it firsthand was when we had a client that was doing self-driving cars. Those companies were not, at a scale to go public yet, but they were raising money, so we were helping them raising money. And those were really one of the coolest companies, coolest clients we had. And I really was super drawn to them. So after 2 years of banking, I decided to actually quit the finance job and completely embrace the self-driving world. So I joined a company called Pony.ai, and I became like a product manager slash like a go-to-market person there. And it was really a fascinating growth trajectory. Back then, when I joined the company at Pony, they had 300 people, and then they've grown all the way to over 1,000. And I was trying to go public by the last time I was there. So that was my foray into seeing how these AI models actually get productionized in a system.
Yeah, super interesting, and always nice to kind of, it's always risky joining a startup. You never know what's going to happen. It could be a high-flying startup, and then 2 months later, it's dead, right? For you, had an opportunity to join one that was in AI and also ended up going public. So that had to be an interesting experience just to see, even at 300, right? 300 is not large compared to the size of companies that are IPOing.
Right. It was interesting, but the market took a very sharp turn. After I left Pony to go to business school at Harvard, but 2021 was kind of the hype cycle, the peak of the hype cycle for not just AI, but generally in the software market. It was software companies were trading at 30x revenue multiples on average, and it was a and everybody was fundraising at insane valuation.
Right.
But then the market had a reckoning. And we kind of had we're still sort of in this broader tech downturn, but AI was sort of the only shining star in this market. So the market is a little different, but still, I think, it's quite interesting to see how a startup can go through the ups and downs.
Yeah, no, you're exactly right. I mean, 2021 where it was the golden age, right? And then everything went off a cliff, except for, like you said, folks who were actually building AI native startups. So your experience with AI at Pony kind of, opened your eyes to the promise, the potential of AI itself. I'm curious what you saw. Well, I guess at what point did Relari come to mind? Was there a particular pain point that you saw where you said, look, I need to solve this? And if so, what is it?
Yeah, so I decided to go to business school between 2021 and 2023, and those 2 years was really, I think, an inflection point for the AI industry as well, because when I was deep learning was sort of becoming a thing when I was in college, and it had a very good run, empowering lots of full machine learning applications in enterprises, and self-driving car was also one of the the great examples of, classical AI applications. But really, it wasn't something that everybody can feel and touch in their daily life. But since ChatGPT came out, like it really became, you know, like a thing that everybody can interact with and see the
Mhm.
power of on a daily basis. So I think the market also, transitioned quite a lot from the people in the industry perspective, even though from outside it seems like it blew up from nowhere. And when I was in business school, I met my co-founder Pasquale, and he was doing his PhD at MIT, and his research is on the reliability and safety of AI systems. So
Okay.
he uses self-driving car as an example of his research. So that's kind of how we initially bonded. But then when the LLM boom came about, we just started sort of like brainstorming ideas in that space to see what would make sense for us to contribute to this new way of innovation.
Yeah, so that
And
was
the
what was that your, because this is 2022, right? So your first year or second
Yes,
year in HBS.
right. So we were always like, meeting every week, looking at what's happening in the market and thinking of ideas. But we didn't actually start Relari until we both graduated. So we graduated a couple months apart. But then it was like late 2023 when we started Relari formally as a venture. Yeah.
Okay,
Uh,
nice. And like, what did you see? I mean, obviously you're in this LLM space. You saw it as a huge market opportunity. I guess was what particular portion of the market did you see there were issues that you particularly wanted to attack?
yeah, for sure. So I think, what became increasingly like obvious to us in the LLM world as we see it kind of explode from the initial craze to, how people using it and some of the problems was actually surprisingly similar to how the self-driving car or the robotics world have experienced in the early innings. If you think about LLMs today, most of the applications are like either at the demo level that they haven't reached
Hmm.
through true production use,
Hmm.
or they're being used for things that are not very important. I mean,
Right.
when you hear about LLM and the promise of it, everybody talks about how it's going to, revolutionize the way people work, like how it's going to completely change so many industries. But it's not really happening yet, right?
Right.
Most people are using it on small things that don't really matter, or they see it as a toy and they have fun with it. I'm not saying those use cases are not important, but so much value still hasn't been unlocked. And this has happened in the self-driving car industry as well. That industry was stuck in a demo phase for
Hmm.
over 10 years. You've heard about self-driving car demos all the time, like Waymo were like first releasing this in like even before 2010, and they were like testing these vehicles all the time before they finally opened up to the public a couple of years ago. And I think, there is going to the LLM powered applications are going to go through a like similar hardening process for them to be truly used in
Right.
a lot of these mission critical applications that we hope to use them on, right?
Mhm.
And with the gap we see is that, you know, the market doesn't seem to really like a lot of the tooling around building AI today. It's still built for folks who are primarily experimenting with it, building prototypes and building demos. But there is a like a big gap in terms of people who actually want to productionize these AI
Okay.
applications. And we understand that in the self-driving car world, for example, when they went through that process, there are huge companies built and they're either built in-house at these companies, like for example, Pony, we had like over 200 people working on the data and infrastructure to
Mm.
power the whole development ecosystem. Or there's a company called Applied Intuition. That's a $6 billion company that's building the testing and simulation infrastructure for everybody who's building self-driving cars. And we think that level of sophisticated infrastructure has not been built yet. And
Mm.
without that, it's very hard for this industry to kind of move beyond the initial phase of impressive demos and things people can use on and off. So that's where we see the opportunity. My Pasquale's background really is in his research is on how to make these things more reliable and how
Yeah.
to make these production grade. So we thought we have a pretty good understanding of how to get there and wanted to start a company to contribute.
Yeah, it's interesting looking at kind of the market of different AI products out there. Like what started
Mhm.
as something kind of niche, now it's, if you look at a market map of all the different sections and applications of AI, it's exploded. A lot of what you see is kind of B2C because it's easier for consumers to go ahead, adopt AI, use it in their everyday life. But on the side of the enterprise or even mid-sized businesses, it's like, look, we've got to take this extra step to think through how this actually applies. Because one, we don't want our customers getting pissed. Two, we don't want the government getting upset. And now we've got regulations and all these other issues that are, hey, look, we'll go through, to your point, this phase where we're implementing demos. We're not necessarily at the point where we want to deploy this at large scale. So, and I kind of caught, when you had mentioned your co-founders, his what he studied, right? While at school, I kind of picked up on that. I'm curious, as you guys identified that issue, how did you think about solving it? What's the Relari approach to solving?
Yeah. So our approach was that, we first built a number of LLM-powered applications ourselves and try to get people to use it. And then we try to understand the development process of LLM applications and to see how they can become more and more robust in the iteration cycle. The difference between LLM applications and traditional AI applications is a lot of times you're building on top of an API. You're building on top of OpenAI's model as opposed to training the model from scratch. So it is a little different from the tooling that was built to support the classical ML world. And really the big part that we are focusing on is the evaluation piece.
Okay.
Because the reason evaluation is important is that you can't really improve what you cannot measure. And when you say it's demo ready, usually what people mean is that the output is not consistent. Sometimes there's hallucination. AI can make up answers and it can't, give you things that are irrelevant. But how do you know how bad or how good it is if it's ready for production? You need a robust system to tell you quantitatively how well it's performing in certain areas and how poorly it's performing in other areas, so you know how to apply target fixes. And right now, there really isn't a very robust system to evaluate how good these systems are. And most people, the way that they develop AI applications is they kind of develop it and they try themselves a couple times, or and then they eyeball the answers to see how good it is. And we call those type of development as like you're developing the AI application based on vibes.
Right.
And as opposed to having a rigorous process to evaluate it and to test it. So at Relari, we focus on this problem. And the way our approach is different. As you can imagine, there are a lot of evaluation tools already on the market, even when we started building it. The way our approach is different is that we focus very heavy on a data-driven approach to test and evaluate these systems. And the reason you have to do that is because AI systems are non-deterministic. So if you have if in traditional software, you write a unit test and you test the software to see if given an input A, does it produce output B? But it won't work for AI because it's non-deterministic, meaning that every time you put the same input doesn't mean it's going to pass the same test again.
Right.
And also there are all sorts of like corner cases you have to protect against because, the user's input is usually, can be anything. And people can use your AI tools in a way you don't imagine. And that can really cause a lot of problems. So our data-driven approach is that we would generate a lot of synthetic data to basically spam at people's AI applications and see how they perform in all of these different scenarios. And then as a result, they will get a much more holistic understanding of how well their AI system is working.
Yeah. So two questions. I want to come back to this concept of synthetic data. I think there are folks who may not necessarily know what that is. Yes. So let's come back to that. But I do want to talk about when you say, is the AI good, right? What does that mean? Does it simply mean that the output is what we desired for it to be? Or is there more to that?
Yeah, that's a very good question because unlike, if you do like a lot of the tests we can design to judge whether something is good or not, for AI, it's oftentimes very nuanced. Like, is an answer from ChatGPT good enough? Like people all have different preferences, right? Sometimes people say, I want a more simple answer. Sometimes you want a more, courteous and verbose answer that ChatGPT often produces. And the way we think about what's good and bad is very application specific. So our customers are usually vertical AI companies. They're they're either like an AI startup or like a large company developing an AI product on top of their existing product. So they have a very specific cohort of like customers. Like for example, if it's like a lawyer copilot, something to help the lawyers, there's a particular style of answering questions and a particular rigor that the AI needs to produce. And it's, as you can imagine, different from how normal people communicate. And so what's good to them is very different from what's good to other people. So the way we do it is that we create custom metrics based on what the lawyers, their users perceive as good and bad, and capture those and develop the custom set of metrics to judge if it's good or not. And you may ask, like, okay, so how did that work? So the custom metrics can be sometimes calling another LLM that's trained specifically to judge if an AI answer is up to the standard of what an industry expert would think is good. And that another LLM can be trained using the data from the historical data. So a lot of times when customers come to us, they've already had like experts label some of the things that good and bad. Like they've run experiments themselves and they had a lawyer go through all of the 100 questions and answer to see if it's good or not. We can take that data and then train an evaluator that's very closely aligned to how a lawyer would think good and bad, and then judge its performance.
Yeah, I can imagine a scenario where the output they want is kind of a text response, but what if they're asking for analytics? Like historically, LLMs have been very bad at math and at analytics. If the output request is analytics, are there ways that you can help companies get to a better response if it's, hey, I want to see, basically if you're querying a system of data, maybe it's all in Excel, and you want a response that requires some combination of data to be pulled together, and you need it to be good, right? You need it to be accurate based on what the prompt was.
Yeah, that's a very good question. So what you're describing is actually, a multi-step system. So it's not just the model producing an answer, right? There is a step for the model to transform the query into maybe a SQL query to query some database, or maybe it's writing some code to analyze the data. And for these multi-step systems, it's important to understand the performance at every step. Like, for example, when I ask for some data, is this producing the right SQL query? And because if it's not, then it's not going to give me the right data to work with in the first place. And then if I get the right data, is it going to be able to analyze it correctly? And after I get the analysis, is the LLM able to synthesize and summarize the information in the right way to produce it to the users? So all of each step, we're going to come up with specific metrics to measure how good it is. Like, is it like generating all of the intermediate steps correctly, essentially, so that an LLM developer, an AI team can correctly judge if it's doing a good job of the desired system outcome.
Yeah. Okay. Awesome. And let's come back to the conversation around synthetic data. And please correct me if I'm wrong, but I thought what I heard is, in terms of like the core of what you all are doing is helping companies to develop synthetic data that will increase the accuracy of their outputs when leveraging LLMs. Did I encapsulate that correctly? Or would you adjust what I said?
Right. It's along the same lines. Essentially, synthetic data is a means to an end. So you use synthetic data to help you test and evaluate a system at a larger scale than you can with real data. And the way synthetic data works is I can maybe use a self-driving car example as well. That usually help people understand. So before Waymo, like the largest self-driving car company, released its cars to take passengers, fully driverlessly without a driver in Phoenix and San Francisco, it tested about 20 million miles on the public roads. So it had like cars with like safety drivers driving around, collecting 20 million miles of data to train and test the system. But what a lot of people don't know is that it actually tested over 20 billion miles in simulation. And that's over 1,000 times larger. And simulation is essentially synthetic data that's at a much larger scale, simulating a lot more scenarios. And the way synthetic data, the reason they have to use that is, as you can imagine, that every time I change the code on the car, like the car software, then it technically is supposed to perform well in all of the scenarios, in rain, in snow, in traffic jams, when somebody jumps in front of the car. But if you test it on the real road, it's very hard to kind of encounter all of that every time, right? So you really need sync data and simulation to test all of the scenarios every time you change something. And so as a result, that is heavily leveraged as a systematic way to stress test these systems as you develop them. And it is the same thing here in LLM systems. Every time you change the prompt, you change the model a little bit, you change the parameters of, say, a RAG system, the agent, behavior. You have to kind of test it in all of the scenarios that your system is designed to perform and see how well they respond. Only then you can do it. And the reason synthetic data is used in LLMs as well. Usually people think they have a lot of data already.
Right.
But the data, they're like, oh, I already have all these data. Why do I need synthetic data to test? The reason is that in most cases, people's data is like, let's say you're like a healthcare company trying to build a healthcare chatbot to query like medical notes or stuff like that. The data you have is like all of those notes, all those documents. But what you don't have is the desired input and output for an AI chatbot. So what we synthetically generate is the desired conversations that an AI is supposed to give. And you use that as the ground truth to test against. So that type of data, people, unless they have a lot of humans label a large quantity of what the conversation is supposed to look like, they usually don't have that data, even if they have lots of data that's collected for other use cases. So that's kind of how we use synthetic data.
Interesting. So your perspective on synthetic data, or I guess your approach on synthetic data, in the case where we're talking about this healthcare company, right? It's not that you're going to go and produce patient records, synthetic patient records. It's let's create the conversations that get us from that point A to the desired output point B. So it's the conversation itself that is synthetic, and the customer's data, those patient records, are a part of a different data set that you're using to inform the output.
Yes, exactly. So our synthetic data pipeline, the way it works is that we take that patient data or the records, usually not patient data because they can't really use patient data for training or anything like that. But it's like the knowledge corpus. For example, like the company.
Yeah, let's be safe. And we don't want to violate anything around PII, right? So let's use safer examples.
Right. There's a whole industry of the traditional synthetic data industry created just to obfuscate the PII data for healthcare and finance industry. But we're talking about a different kind of synthetic data, which is synthetic application data. But the way we do is we take like 3 different inputs to generate the synthetic data. The first thing is the application logic. Is it a RAG application? Is it an agent? Is it a combination of all of those? Does it require math? And we map the application pipeline. So that's the first step. The second thing is that we take the environment data. What I mean is usually like the documents, like the patient records, or the things that an AI have access to. But a lot of times it's document Q&A, then you have to give me the documents that is supposed to do the Q&A on. And the third thing is what we call seed example data. So we take a small sample of the data that customers typically have, which is like some example questions people ask and some example good answers people produce. And essentially our pipeline will blow that up to like a much larger magnitude so that they will have a lot more questions and answer pairs, and also all the intermediate steps that they can use to stress test their system.
Yeah, I'm curious how do you actually approach that, right? Like, I don't know if you have a specific vertical that, well, you did mention you're working with vertical AI companies. Are there specific verticals you focus on? And I'm curious about that because, that probably determines the question and then the desired output, and probably requires some level of understanding of that industry, just giving each industry has its own kind of lexicon.
For sure. So the benefit of like LLMs, because we use LLMs heavily in the synthetic data generation process as well, plus customers provide us a small sample of data to begin with, we actually surprisingly don't need to be super knowledgeable about the space they operate in order to generate high quality synthetic data. And today we have customers, in the security space, compliance space, and in the finance space. And, I think they do coalesce around the industries where accuracy and quality is important. Where they can't just have an application, they build it and then they ship it. We don't have any consumer companies. All of the vertical AI companies we're building for usually businesses. So, but to your question, like we don't really need to. What matters more is the application architecture. Like, is this a chatbot? is this like, for example, there are AI applications that are filling out security questionnaires, then it's not
Mm.
really question and answers. It's just that given the security policies, how do you answer these questions? And there are applications like, client intake forms, and is it getting the right information from the clients? And a little bit out of the way, we have even companies doing coding agents using AI,
Right.
and then we generate synthetic code blocks as
Mm.
ground truths that they can test based on certain instructions. So all of those maybe sound pretty different, but we're able to do with our system.
Okay. That makes sense. So it's just ensuring that the output is very specific to whatever, business
Yes.
outcome I'm looking for. If we're thinking about Chat GPT, I can ask it whatever question, and OpenAI, I mean, they want it to be directionally correct, but it's not mission critical that the answer
Mhm.
is directionally correct, right? You
Yeah.
see it's wrong, you'll just ask the question in a different way inside of Chat GPT. Different if I'm a business, right, and I'm filling in customer data, I want to make sure that I'm not putting a phone number in the credit card space, and I'm making sure that I understand that the output is actually very customized, very unique to my particular use case.
Exactly.
So with that, it sounds like a lot of work to get both of those pieces of the puzzle. Let me figure out the variety of questions that can be asked, and then what's the optimal outcome based on what you do, Mr. Customer? What's your approach? Like if I'm a potential customer for Relari, how do you guys even get that done? It seems very intensive. Obviously, I'm coming to you because I don't want to do it myself.
Right, right. Yeah, you're exactly right. Most of our customers, the journey typically starts with that, they build an AI system like a chatbot or something, then they manually eyeball. And then they realize, okay, this is not sustainable. Maybe they hired somebody to kind of just eyeball for them, or they build some simple in-house tools. Like they just ask another LLM, is my answer good or not? And these are simple checks. And then once they realize those are not as reliable, or like they need a more systematic way, and they come to us. So by the time they come to us, they already have a little bit of an accumulation of
Right.
evaluation results and have some understanding of like what's good, what's bad. And basically what we do is to take that and then make that into a much more robust and systematic process. And the onboarding process is, for us, it's pretty straightforward. They just provide some C data and describe us to the application. Then we just configure the evaluation software for them to use. And to them, it's actually just a simple API call once everything is set up. And they just call an API to fetch the data set and then run the synthetic questions in their system and then get all of the outputs. And then they send all of their outputs through the API again, and then the evaluation results will be there in the dashboards in the UI. So they basically go to the dashboard and see how the answers are, if it's improving or not improving, and then inspect specific results to see where it's failing and how to improve them.
Yeah, and I'm curious, like that next step, I guess maybe we could call it the last mile, right? In a scenario where I see, oh, I ran an evaluation, we're doing great. Okay, nothing more to do, right? I ran an evaluation, we're doing terrible. What's my next step from there?
Yeah, that's a great question. So today, like for the LLM developers, they typically have three levers they can pull to improve their application performance. If we're talking about a typical application performance, one is that they can do prompt engineering. The other is that they can improve the retrieval process because most applications require getting some data from somewhere to supplement the model. Yeah. So retrieval is something they can improve. And the last one is they can obviously pick different models, and the most extreme case is that you can fine-tune a model for your domain specific use case, fine-tune an LLM. So these three paths are what LLM application developers typically take today. And it's usually not mutually exclusive. It's usually a combination of all of those. And with our evaluation tools, usually it'll be able to tell you like what type of failure mode you're experiencing.
Yeah.
Like, for example, if you're only getting the right data to answer the question 50% of the time, then it doesn't matter how good your prompt is or how good your fine-tuned model is. What you should be improving is the retrieval process. And the retrieval process, there are so many different techniques out there. And you can basically use our tool to have a very granular analysis of how good your retrieval pipeline is working and then improve based on that. If for example, you realize the LLM is not producing the outputs in the correct style or the correct format that you want, even though you tried really to prompt it very well, then that shows what you need is potentially fine-tune the model to match your particular output styles. So all of that is that we basically provide a way to more quantitatively understand how the performance and decompose the aspects so that you will have a better idea of what to try next and what to experiment. Really, folks should have an experimentation-driven mindset and a data-driven mindset of developing these. And basically, we build the infrastructure to support that. But at the end of the day, it's the burden falls on the AI developers' shoulder to figure out the best application architecture for themselves.
Yeah, interesting. So instead of them reaching into a black box to try to solve the issue, it's, let us be more specific. We can guide you in the right direction so we can save you, your team, time and money as you try to solve whatever issue might be there. Given that you're working, in this LLM space, specifically with enterprises and, small, mid-sized businesses, are there industries, is there some way to segment who are the type of companies that are putting LLMs into production now? Who are the types of companies that are more likely to be running models for LLMs, and who just doesn't care right now?
Yeah, I think over the past year, like every company went through a phase, especially if we're talking about large enterprises. Obviously, because the easy segment is AI native startups that were created because of LLMs. Obviously, they're going full steam at it.
Yeah.
And when we think about mid-sized or large companies, it has gone through a phase of like severe FOMO. Pretty much all boardrooms, like people talk about AI, is like, how can we incorporate AI? And because it touches almost all industries, right? And if we looked at like the shift from on-prem to cloud computing and the shift from web to mobile, and there are winners and losers in every industry because of those technical shifts. And AI is something that people perceive as the next wave that's going to really change how most businesses operate. So because of that, a lot of companies started these AI task forces to kind of just look at every single, business line to see, can we use LLM here? Can we use LLM there? And as a result, a lot of pilots got spun up. But as you can imagine that if you're just applying like a blind, sweep, try to apply LLM in a lot of things, then not all use cases make sense. There are a lot of use cases actually AI is not good for, or not good for yet today. And as a result, I think we've already gone through the first wave of churn, like in the industry broadly, like a lot of the applications, people realize, okay, this actually doesn't make sense. Or it seemed to make sense, but when I ran it, it doesn't improve my ROI in a meaningful way. So those applications are fading away. But still, a large proportion of them are sticking around. And it's hard to pinpoint which industries specifically they are, because even within a single company, there are usually a lot of different use cases. I will say, like for large enterprises, over the past year, majority of the deployments in production are still internal applications or applications that still have human in the loop, meaning that the AI output is not the final output, and you still have human checking the answers or checking, some of it, so that you have guaranteed reliability falls on the human. But I think we're going to see more and more that shift from the internal facing applications to the more customer facing applications. And also the human in the loop will go lower and lower in all of these applications where as these systems perform better, you want to offload more work to the AI as opposed to always having human. And the self-driving car is the same thing as well. Like you have the Tesla autopilot type of self-driving, which it does drive part of it for you, but you're constantly watching. So the value to you is like, it's not really that it can function as a taxi driver for you on your behalf.
Yeah, interesting. Kind of changing gears here, as you thought about building out Relari, what's the team look like today? I know your co-founder came from a technical background. You've got this combination of go-to-market as well as this computer science background. So curious what the team looks like today. And then in the early days, like what were the types of talent you needed to bring in to build out the platform?
Yeah, so
I guess it
we're
still is early days.
it is still early days, and we basically like started the company late last year, just me and my co-founder Pasquale, and we went through the Y Combinator accelerator in the winter, and then we raised a seed round. So now we are actually in a position to actively hire and expand the team, and the people we're looking for is pretty much all technical talents of different kinds. So we do want more research engineer, AI engineer type of folks to help us design and innovate on the best in class evaluation and synthetic data technologies. And but at the same time, we also need product full stack engineers to help us build out the build more enterprise features, the security features, and all of those to serve a broader audience. And one thing about us is that part of our stack, the evaluation framework, is actually open source. So we get some open source contributors from very large companies like PwC to help us build part of the stack as well. But I think it's going to be the combination of like core team hires and also the community contributing ideas to evolve our product.
Yeah, awesome. And I know you mentioned the research-driven folks on the AI side, and then there's this other, I would love for you to kind of compare and contrast why someone with a research background, and then, why do we even segment that from someone who's actually, look, I'm responsible for production.
Yeah, I think, at the practically on a day-to-day basis, it's very hard to separate at a company of our scale. But folks come in usually have a different, goals and, different backgrounds and interests, right? So for the more PhD type of research engineers who work the research labs, a lot of times they're, if they want, they can spend more time innovating on reading papers and comparing the best results of like different evaluation techniques, different ways to generate synthetic data, different ways to train and fine-tune models, and run experiments. And we also plan to publish papers on our techniques. But on the other side of the actual business, we have lots of customers to serve. And product engineers typically are more excited about like, shipping the product and talking to the users and customers to see how to improve, our whole user experience and how to bring the best in the research into production and what are the ideas that actually work for customers. And also, I think we are at a front row seat to look at how all of these different vertical AI applications unfold in different industries. So it's quite, kind of a vantage point to actually understand what AI applications are, to your point earlier, like working and which ones are not. Yeah.
And you mentioned you got a bunch of customers to serve on one side. Generally, I mean, it sounds like from what you say, they've done some AI experimentation already. When you go to market, you're having conversations with these potential customers, like who is the person are we going up to the CTO? Do they have a chief AI officer? You also mentioned startups. Is it, hey, look, I'm a technical co-founder, help,
Yeah, yeah. Yeah, for startups, it's very straightforward. So usually the founders understand the pain point and then make a decision on it. At enterprises, what's interesting to us from what I've seen so far is that every organization has a little bit of a different setup, because AI is like this new shiny thing that everybody wants to, collaborate on and work on. So, and this AI task force that are initially formed usually are still the driving force behind it. And sometimes it's made up completely of the IT or engineering org. Sometimes it's the business units, innovation arms. Sometimes it's the product managers. And it's a really diverse, and also there's also traditional ML engineers and data science organizations that are very natural takers of the LLM work streams. So it really varies. And we have seen a couple different personas who will buy our products. But overall, I think anybody who's building an AI product, especially in a large organization, would need some tooling like ours to bring to production.
Right. And I know we're coming up on time here, but just two more questions, and I'll toss them both to you at the same time and we can tackle them. The first question is, from the perspective of Gen AI, anything that you say, hey, you would think that folks should be looking out for? That's part one. Part two is Relari AI, anything you all have that you like to announce, that you like folks to be aware of or keep an eye out for?
Yeah, sure. So first of all, for Gen AI, I think the majority of the production use cases that we have seen our customers doing are primarily still around text or code or like these type of modalities. But as the multimodal models get better, And we've seen from announcements this year with like voice, image, video, like there are really a lot of different possibilities out there. Today, like the voice, video, and image applications have not really, being taken as seriously as the text applications to be deployed on people's daily basis. But I think that's gonna change. And as you put all of these different modalities together, it really, if you think about AI's capability, it can do a lot more than people who just ingest text and output text. And that's really exciting for us. And coming from the self-driving world, that was primarily visual. And we think, for us as a modality agnostic testing framework and seeing that data framework, we can also support customers in that aspect as they onboard more modalities. And from our perspective, the product perspective, right now we focus primarily on like the test aspect. So we generate very good metrics and very data for people to, to understand the performance. But one of your questions earlier was like, what's next? And actually, we are working on a number of features to directly auto improve people's pipelines based on the metrics. So one example is that we are helping some beta customers systematically fine-tune domain-specific models. So fine-tuning is a process where you try to adjust the model a little bit, the weights a little bit to make it better performing in your specific application. And the process essentially is that you put a big data set together, and then you feed it at the model, and then you have a loss function, and then it converges, and then you get a new model with different weights. But that process essentially is still a data-driven approach where you have evaluation in the end to see if your fine-tuned model is actually performing better or worse in all these different aspects. But actually, when you have that data, the synthetic data as well to train the model, plus the metrics, there can be like an auto improvement loop that's in it. And the same thing for prompts. The prompts can be auto optimized based on the data set and the metric you're trying to optimize. And same thing with the parameters of retrieval and all of that. And we're working on a process where, some part of the optimization and improvement process is automated so that people don't have to, try to run experiments. And they still have to run experiments, but only on the high level. But on the local level of optimization, it can be done automatically using our system. So I think that's like a much needed feature that many of our customers are asking for. So stay tuned as we announce those.
Yeah, it's going to be super exciting, and I'm excited to keep up to date because, like you said, most applications are focused on text. You also got images, and then we got teased with Sora not too long ago. So there's a bunch of folks trying to leverage kind of Gen AI for video, which will be another world for you all to enter into. So super excited about that. And, I guess lastly, for anyone who you did mention you're hiring, so for folks who are tuning in who may be interested in sending you a resume, where should we direct them? And then even potential AI startups, enterprises trying to build AI, where can we send them to look for you?
Yeah, of course. So we are a small company for talents looking to know more about us or companies potentially interested in our product. They can just go to our website or email us directly at founders@Relari.ai. Just founders, and you'll get to both me and Pasquale. And yeah, looking forward to receiving those notes.
All right, awesome. Well, Yi, thanks for the time. This has been super informative. The conversation around Gen AI, LLMs in the future. I know a lot of folks are excited about this, and you guys are certainly in an exciting space. So definitely look forward to staying in touch and keeping up to date.
Yeah, for sure. Really enjoyed the conversation. Thank you so much for having me, Darius.
Yeah, for sure.